Hi everyone, this is my first video on solutions as I have clearly mentioned in a short video. So we will start our video with solutions. The topics we are going to discuss we have already mentioned in a short video. So firstly, in our daily life we come across a variety of solutions. We come across a variety of solutions in our daily life, but there is a difference in between the solutions. Solutions are basically dependent on the solvent we are using, and the solvent decides the nature of the solution, whether it is going to be solid solution, liquid solution, or a gaseous solution. So, in our daily life, we come across a variety of pure substances, and the pure substances are commonly known as mixtures. But there is a difference in between their properties, like brass is an alloy and German silver is also an alloy. Brass is an alloy of copper plus zinc, and German silver is an alloy of copper plus zinc plus nickel. Copper, copper plus zinc plus nickel. And there is a difference in between the properties of these two alloys. So we are going to discuss about solutions. Basically, what are solutions? These are homogeneous mixtures of two or more components, and generally the component that is present in largest quantity, as we have explained previously, decides the nature of the solution, whether it will be of a solid solution, liquid solution, or gaseous solution. So the component which is present in greater quantity is known as solvent, and the component which is present in less quantity is known as solute. In this unit, we are going to discuss about binary solutions. Binary solutions are those solutions which consist of two components only. But in a solution, we can have two or more components. For example, we have 3 or 4 kinds of solutes and a solvent. But these 3 or 4 kind of solutes generally are not under the class of binary solution. Here we are going to discuss only about the binary solutions. So these 3 kinds of solutions, firstly we will discuss about gaseous solutions. In gaseous solution, the nature of solvent will be gas, and as the nature of solvent is gas, the solute can be gas, liquid as well as solid. We have some kind of examples. If the solvent is gas and solute is also a gas, it can be mixture of gases like O2 plus N2. If we have solvent as a gas but liquid as a solute, then an example can be a solvent like chloroform mixed with a gas. Again, if we have solid as the solvent in a gas if we have solid as the solute in a gas solvent, then it can be camphor is a solid, and when it is dissolved in nitrogen gas. So all these are the classes of gaseous solutions. Now if we discuss about liquid solutions, then in liquid solutions solvent will be a liquid and solute can vary. Solute can again is of gaseous nature, liquid nature, and of a solid nature. If you are using liquid solutions with a gas solute, then it can be example O2 dissolved in water can be a good example for this category. And if liquid in liquid, then we have ethanol dissolved in water. Here liquid in liquid category, we have two more different kinds of subcategories under this, whether they are miscible or immiscible, and the third category also, that is partially miscible. Miscible and immiscible solutions are those solutions. Miscible are those in which both of the components are completely soluble, like ethanol in water, and in immiscible both of the components are completely immiscible. For example, I am discussing about miscible. In miscible, both will be completely soluble. Here I am taking the example of ethanol and water. Ethanol and water. These two kinds of liquids we are using, one as a solvent and another as a solute, are completely miscible. So here the nature will be whether they will be completely polar and they will be completely non-polar. So the solute and solvent will be completely miscible if both are of completely polar or non-polar nature, and if they are immiscible, and if they are immiscible, then one will be polar and the other will be non-polar, like cyclohexane plus water. The third category is also partially miscible liquids. Partially miscible liquids are those liquids which are not exactly similar in nature and also not completely dissimilar in nature. For example, if we dissolve ether in water, comes under this category. Now let's get back to the point. When we were discussing about solid as a solute in liquid solvent, so solid as a solute in liquid solvent, here we can use glucose, which is a solid dissolved in water. This comes under this category, which is also a liquid solution, but here we are using solid as a solute. Now the third kind of category is the solid solutions. Solid solutions are those solutions in which solvent we are using is a solid, and solute can vary. In the same way, solute can be of gaseous nature, it can be of liquid nature, it can be of solid nature as well. So when it is of solid nature, it will be an alloy like copper dissolved in gold, like copper dissolved in gold. And if you are using liquid in a solid solvent, it can be amalgam of mercury in sodium. We have heard about NaHg, it is sodium mercury amalgam. and the last one, when gas as a solute in solid solvent. So here example is hydrogen solution in palladium. So these were a few classes of solutions. Basically, we have discussed about solutions till now, that they can be of three types: gaseous, liquid and solid. Gaseous solutions, solvent will be of gaseous nature. In liquid solutions, solvent will be of liquid nature, and in solid solutions, solvent will be of solid nature. Now we will discuss about the composition of solution. See, till now we have discussed about solutions, and I have provided you a few examples of those solutions, but we don't know about the solution composition. What will be the composition, what amount we are using in these. So now we will discuss about expression of composition of solutions, and we can express the composition of solution in terms of concentrations. Now we have a few kind of concentration terms that can express the composition quantitatively. The composition can be of two types. It can be of qualitative and quantitative. For example, we are using a solution. If it is dilute or concentrated, it is only a qualitative information. But what kind of concentration it is, what amount of solute we are using in a solution, we can't predict it on the basis of only qualitative information. So for expressing quantitative information of composition, we need some kind of expressions, and these expressions are termed as concentrations. So these concentration terms represent composition quantitatively. So firstly we will discuss about mass percentage. What is mass percentage? देखो, जो मास परसेंटेज होता है, जब भी हम किसी कंपोनेंट की बात करते हैं, फॉर एग्जांपल वी हैव डिस्कस्ड प्रीवियसली that a solution like for solid solution we are discussing when liquid was the solvent and solid was the solute, like glucose in water. Say I am saying 2 gram of glucose is dissolved in water, so the amount of the less amount here is 2 gram, and 2 gram will act as a solute. So if we are discussing about mass percentage of a component, then it will be mass of component in solution divided by total mass of solution and into 100. So if I am saying we have a 10% glucose solution in water, what does it means? It means 10 gram of glucose is dissolved in 90 gram of water, so that the amount of resulting solution will become 100 gram. So that the amount of resulting solution will become 100 gram. So if we are calculating here the percentage, then mass percentage will be 10 gram will be the amount of glucose, that is the mass of component, and it will be divided by the total mass of solution. You can say the total mass of solution will be 10 plus 90 is equal to 100, and into 100 it will result in 10%. So that is why here we are saying that it is 10% glucose solution. Fine. The next composition term we will discuss here is the volume percentage. Is the volume percentage. It is similar to the mass percentage and it is equal to volume of component divided by total volume of solution and into 100. For example, here liquid in liquid solution category comes. If we are discussing about 10% ethanol solution in water, what does it means? It means 10 ml of ethanol dissolved in water such that total volume of solution becomes 100 ml. So similarly, volume percentage will becomes 10 by 100 into 100 and it will become equals to 10%. There are many examples under this category, as you must have heard about a car cooling agent. We can say antifreeze agent. We use ethylene glycol. कार वगैरह में यूज किया जाता है ये for cooling the engine, and it lowers the freezing point of water to a very lower temperature in approximately minus 20 to minus 25 degrees Celsius. Now the third term we are discussing about concentration composition is mass by volume. Mass by volume percentage. It is used in normally pharmacy or medicinal industry, where we divide mass of a component by its volume. If mass of solute is dissolved in 100 ml of solution, and we can use strength here also. Strength is another concentration term, we'll discuss it later. Now the next term is ppm, which is parts per million. It is used to express the concentration where trace amounts are required. Normally, for expression of pollutants in water or atmosphere, we use this concentration term because these are very less as compared to the other concentration terms. So what it is? ppm is equal to number of parts of component divided by total number of parts of all components of solution and into 10 to power 6. For example, ppm can also expressed in terms of mass to mass, volume to volume and mass to volume. For example, if we have a liter of sea water which weighs 1030 gram, which dissolves oxygen, that is equal to 6 into 10 to power minus 3 gram. अब यहाँ पे सोल्यूट क्या होगा, जो O2 जो है it will act as a solute, or you can say one component, and this sea water it will act as a complete solvent, or you can say solution. This is the total weight of the all the components, so we can take it as a solution. अब अगर हमें यहाँ पे ppm में कंसंट्रेशन निकालनी है तो वो क्या होगा, 6 इंटू 10⁻³ divided by 1030, and it will becomes equal to 5.8 ppm, or 5.8 into 10⁻⁻6. Now our next concentration term is the mole fraction. जो मोल फ्रैक्शन टर्म होती है, we use chi symbol for expressing mole fraction concentration. How we can express mole fraction? It is expressed as number of moles of the component divided by total number of moles of all the components. Of all the components. For example, if we have a binary mixture that consists two components A and B, where Na is the number of moles of A and Nb represents the number of moles of B, so mole fraction of A will be equals to Na divided by Na plus Nb, where the numerator denotes the number of moles of component A and the denominator denotes the total number of moles of all the components. If we have 3, 4 or more components, then the denominator will consist of number of moles of all the components. Now similarly we can find out the number of mole fraction for component B, and the sum of mole fraction of both the components will be equal to 1, and if we have other components, then the sum of mole fractions of all the components will be equal to 1. Now similar to mole fraction, we have a term that is equal to mass fraction. That is equal to mass fraction. In mole fraction we were using the number of moles of components, but in mass fraction we will use mass of a given component. For example, for component A, it will be WA plus WB, that is the sum of masses of all the components, and WA is the mass of component A. And similarly, as mole fraction sum was equal to 1, mass fraction sum will also equal to 1. Now the next term for concentration, it will be number 6 or 7. Let me check. It will be number 6. Molarity. We denote molarity by capital M, and it is equal to number of moles of solute divided by volume of solution in liters. अगर हमारे पास जो सॉल्यूशन का जो वॉल्यूम है वो लीटर्स में नहीं है, देन वी कैन कन्वर्ट इट इनटू लीटर्स. फॉर एग्जांपल 1 meter cube contains 1000 liters. and 1 liter contains 1000 centimeter cube, and 1 liter is equal to 1 decimeter cube. Okay, now if I'm saying that we have a 0.25 molar solution of NaOH, then it does means, I'm so sorry, then it does means we have 0.25 moles of NaOH in 1 liter of water. Now the next concentration term is molality, and we denote it by small m. We express molality as number of moles of solute divided by mass of solvent in kg. Mass of solvent in kg. For example, what does 1 molar solution mean? If we have 1 molar solution, that does means 1 mole of solute dissolved in 1 kg of water. 1 molar solution in water does means it. Okay. Now the next another concentration term is normality. What is normality? We denote normality by capital N. It is similar to molarity, but in molarity we were using number of moles of solute, and in normality we will use number of gram equivalents of solute. Number of gram equivalents of solute divided by volume of solution in liters. Now what is this gram equivalent term? Number of gram equivalent. See, in molarity we were using moles of solute. Now what is number of moles? It is equal to weight of component by molar mass. Okay. Now here what will be gram equivalent? It is number of weight by equivalent weight. Weight by equivalent weight, we can use W by E. And what is this equivalent weight? Equivalent mass of an element is equal to atomic mass by valency of element by sorry, we can use the term mass here instead of equivalent weight. It is equivalent mass. It is again equivalent mass. So equivalent mass is equal to, because that was atomic mass in number of moles, not atomic weight. So equivalent mass is equal to atomic mass by valency of the element. For an acid, it is equal to molecular mass by basicity. And for an base, it will be atomic mass by acidity. So now number of gram equivalent will become weight by atomic mass into valency. Now put this in the formula of normality, which was equal to number of gram equivalents of solute divided by volume of solution in liters. So it will become equal to weight by atomic mass into valency divided by volume of solution in liters. Now this term will be equal to molarity, and normality will become equals to molarity into valency. For an acid, this valency will be equal to the basicity, and for an base, this valency will be equal to the acidity. Now there are few relations that will help us in calculating the concentration of solutions on dilution. Relationship between volume, normality and molarity. One relation is equal N1V1 is equal to N2V2, where N1 and V1 are the normality and volume of one component, and N2 and V2 are normality and volume of another component. Similarly, we have M1V1 is equal to M2V2, and for n number of moles, M1V1 by N1 is equal to M2V2 by N2, where N1 are the number of moles for component 1 and N2 are the number of moles for component 2. Now if we are going to mix two kinds of solution on mixing, one solution have N1 normality and V1 volume, and the another have N2 normality and V2 volume, and we have to find out the normality for the solution on mixing. Then it will become equals to N1V1 plus N2V2 is equal to N3V1 plus V2, because on mixing the volume of solutions will add on but the concentration will change, so we can predict the normality, or you can say concentration of the mixture, by this method. Now one important thing I also want to discuss, all the concentration terms we have discussed till now. I just want to ask or tell that out of molarity and molality, this is molality and this is molarity, which one will be preferred normally? See, molarity is a function of volume and molality is a function of weight. Volume normally depends on temperature, but amount is independent of temperature. But amount is independent of temperature, so we always prefer molality over molarity. A few terms are also like mole fraction also doesn't involve volume, so we can prefer mole fraction also for representation of concentration. So these are few concentration terms, and in our next video we will discuss a few numericals for calculation of concentration, so that we can clarify easily all these concentration terms, that how can we use these concentration terms for calculating the various amounts or for making different solutions. So thank you.